Thank you for reviewing my final project, Human Factors in AI. For this project, I chose to design a system for the purpose of assisting quality assurance in the area of manufacturing, specifically glass manufacturing as my topic. Commonly, this is called Visual Inspection AI. It is a very attractive solution for machine learning because there is a problem, the cost of poor quality, which can be equal to 15 to 20% of total revenue. In fact, the cost of poor quality is often 100 times the initial price of the part involved. So people are very motivated to improve quality. Machine learning can help. There's a feasibility, which also makes this very attractive. And as a result of both, people really do care. For this project, we were asked to consider the ethical nature of our approach. And so I wanted to call out that the North Star in the human-centered design here will be to build systems that complement humans and not replace them. This is also called Freestyle X. And I particularly like machine learning in this space as quality visual inspection can be tiresome, can be uncomfortable. And as you can see from this picture where the glass bottles are extremely hot, could even present potential danger for the user or the person on the factory floor. So this is a great opportunity for us to take machines which can be very good at these types of tasks and to assist our human workforce with these tools. For this project, we're going to take a very human-centered design approach. So we're going to employ the 3 E's: empathy, expansive thinking, and experimentation. And we're going to take a design thinking approach. So we're going to first empathize, and that means doing a lot of research on exactly what the workflow is like for people who have to inspect glass. We're going to understand what types of issues can commonly occur in glass, and we're going to come to learn where it's critical for us to capture issues within the manufacturing life cycle. After we have empathized, and it's important to observe and watch and listen, and if this was a real product, we would hopefully go and actually meet with some of our users or certainly speak to them and understand, come to a great deep understanding around their workflow. And after we have completed that phase, we would move on to the define stage. The define stage goal is to synthesize all we have learned from our empathy and to define the user and define the needs and create insights. We want to have a project that's narrow enough to be manageable, but not so narrow that it limits us. So we have decided, after doing our research and speaking to our users, that there's 2 critical areas where we can capture glass bottles in the life cycle. One's called the hot end, which is the image you just saw where the glass bottles are still hot, and the other was the cold end. So for our MVP, we're simply going to install sensors at these 2 critical junctures, and this will allow us to then use the ability to ideate later if we decide we need additional places in the workflow. For our user experience design, we need to ensure we understand how our user will interact with the solution. So for this process, we have determined we're going to install camera sensors at 2 critical junctions, and then we're going to train our model on commonly occurring issues within glass. We're going to integrate this system such that when the machine learning model identifies an issue in the manufacturing floor, that glass bottle is then removed from the manufacturing floor. It's removed from the life cycle. So from an initial stage, our user will have limited interaction with the model, but we do very much want to capture the feedback of the users. So we have determined that we will ensure that our users, excuse me, are continuing to assess the results of the model and then compare that to the actual bottles that were found to be defective in some way. So we're going to use that user input and allow that to be our feedback loop. Perhaps they will find other issues that the model is not flagging, or perhaps they will find that the model is incorrectly flagging bottles that are in case actually correct. This will allow us to retrain and make sure that our model is increasingly more accurate. For this project, we determined that we should create some easy way or quick way for us to install the cameras on the factory floor and get some early feedback. So we decided that we would train the model with heuristics. So we took the most commonly occurring issues with glass manufacturing and trained our model to identify those issues. But we wanted to get the cameras installed as quickly as possible to capture that early feedback so that we could address issues with lighting or other areas within glass manufacturing that we have not yet identified as being issues. We could play back what the machine model is flagging and what it's not to our user group, and they would inform us of how to retrain the model and improve that. That's the end of my project. Thank you so much for joining.